Hello, everyone. I graded your quiz, and as you saw, most of you have got some of the parts wrong. So I thought it might be good to make some explanation here and tell you how to do this problem, because I think it's important for you guys to understand how to do the IC and also to deal with the geometry. So let me share the screen on the tablet and explain how this problem is solved. This is the definition of problem. You have two links, AB and CD. AB has 200 millimeter length. BC or CB has 400 millimeter length. AB goes with angular omega of 5 radian per second. So the problem, if you remember, asked you guys to find the omega BC and velocity of C. I try to explain this like a recipe type of method so you can follow. Remember when we have IC, IC is used for the link with general motion. In this case, link BC. You always should have the direction of velocity for 2 points. The direction of velocity for 2 points should know. And the 2 points are obviously on that rigid body. Now, in this case, as you can see, slider C moves back and forth here. So the direction of velocity is going to be horizontal. And point B, which has rotation about fixed point, is going to have a velocity perpendicular to the link AB. Right, so you have these two directions, and if you use this, you can get your IC. The IC has to be perpendicular to both velocities. So I'm going to draw a line perpendicular to velocity of C from point C. This is one line, right? And then I think I may have to move this down a little bit. So let's just do that. Oops. Okay, so now the other line will be perpendicular to velocity of B, which means it's going to be parallel to the link AB. So I'm going to draw a line parallel, and then this is going to be your IC. This point will be IC. Now, before we go to the geometry, the next point is the value of velocity for one of the 2 points should be known. Otherwise, you cannot solve it. this case, because omega AB is given, I can find velocity of B. VB is equal to RAB omega AB. And if we calculate this, is 5 times 0.2, VB is 1 meter per second. Now you can use you can find this velocity, usually use another link, or just the velocity could be given. For example, I could give VC as input and ask to find omega AB. So you could go backward, but in any case, you can find velocity of 1 point from the information that is given in the problem. Now you're going to have to find RBIC and RCIC. This is where most of you made the mistake. Many of you assume that either this is 90 degree, which is not, or it is 60 degree, which is also not the case. Let me show you how you can find that angle. And let me remove this stuff here. Now, to find that angle, there are different ways to do it. The simplest way is to use one line here, horizontal. Right? If I draw a line, oops. If I draw a line here, if this angle is 30, then this must be 30. And if this angle is 45, this angle should be 45. So the overall angle here is going to be 75. Now, if this is 30 and this is 90, it leaves you this guy with 60. And if you go with all of that, this is going to be 45. So you have a triangle with 3 different angles. None of them are the same. None of them are 90 degree. So to find length of R, like BIC and CIC, you're going to have to use the sine rule, which means, let me clean this a little bit. Now that you know how to do it, I'm going to remove all of this and make this all smaller, right? So this is 60, this is 75, and to use sine rule, you can write L or R, let's just go with R, RBIC, which is this length, divided by sine 60 is equal to RBC, which is this guy, divided by sine 45. So from here, you can find RBIC, and the second equation for RCIC divided by sine 75 is equal to, again, RBC divided by sine 45. And from here, you can find RCIC. This is where most of you guys made the mistake. So now if you use those, then you're going to get RBIC is 0.49 and RCIC is 0.546 all meter. Now, if we go back to this recipe things that we started here, the next point will be use the velocity known to find omega of the link. What that means is this. I use link BC and I know velocity of B. Considering at this moment, if this is velocity of B, it looks like B rotates about this point with this radius, then I can write VB is R BIC times omega BC. And from here, you can calculate omega BC as VB, which we know it here, divided R by R BIC, which we know it from here. So your omega BC will be 2.041 radian per second. Now that we know the omega of the link with general motion is known, you can find velocity of any point. On that link. And remember, if this is the link BC, both point B and point C belong to that link, right? So if I want to find velocity of C, VC is simply RCIC, center of rotation from C, that's the radius, times omega BC. And if you substitute the numbers, VC it's going to be 1.114 meter per second. I think this triangle here that somehow looks like 60, 60, 60, these sides look equal. Remember, we don't make these assumptions from the geometry unless it's given like 60 or 60 or whatever. So you had to find the angles to make sure you get the right shape. Specifically, if you draw this by hand, sometimes this angle could look like 90 degrees, sometimes this look like this, are identical, same size, but you have to consider the geometry with the numbers to see how it's done. I hope this clarifies some of the things that you guys got it wrong. And that's it. Thank you, and I hope you watch this video and learn something from it.